you are. As was mentioned, I'm in London, England. It's halfway in the afternoon, and it's almost pitch black already. So it'll be nice when the sun starts coming out earlier. So today we're going to take a look at some of the things around security, compliance, identity management, those sorts of things from the point of view of the cloud. Of course, everybody hears, what is the cloud and why should we use it and what's the point of going to it, and so as a sort of at a high level, going to the cloud can make your life easier in sense of the amount of money you have to spend on local resources internally, the amount of storage space that you need internally, the amount of energy that you consume in terms of air conditioning and heating and ventilation and all that sort of stuff. Reduces the amount of physical security that you'll need in your environment because you don't have all your servers and everything in there, and so on. And moving everything to the cloud, takes a lot of that management stuff out of your hands and moves it over to the Microsoft people to manage. That doesn't mean that you don't have any input or control over any of the security that's happening, but you'll participate in it as part of as a group rather than being totally responsible for it in and of itself. So we're going to take a look at 5 areas, specifically, or 4 areas, I should say. The first section we're going to talk about as an introduction, some of the basic concepts of security, compliance, and identity management in the Microsoft Cloud, specifically, obviously, Azure. Once we're past that, we're going to take a look at the different capabilities of some of the things that is part of the Microsoft Identity and Access Management solutions. Then we're going to take a look at some of the solutions or the security solutions around some of the things that Microsoft does. And then lastly, explore and take a look at some of the solutions and compliance tools that Microsoft has in their system. And then we'll finish off with a bit of a Q&A at the end of the session. All right, so the first section, we're going to take a look at 3 different areas. First of all, we're going to take a look at the idea of zero trust and shared responsibility models. Then we're going to take a look at how to describe what is the common security threats that exist in the world today and some of the ways that we can mitigate against them. And then also taking a look at the different concepts of encryption and hashing and how those can be implemented in the system as well. So everything that we're going to be looking at going forward today are all part of the Azure AD stack. So everything is cloud-based. Everything will be running through Azure AD. And so we need to understand sort of at a high level what are the tools or features that are there to help to protect our assets that live in the cloud. Well, we have to have, we need to look at sort of what our passwords rules are, password configurations. So these include things like complexity. How many characters does it need to have? Does it need to have, alphanumeric characters only? Does it need to have a capital letter? Does it need to have a non-alphanumeric character? All those sorts of things. Also, how often does it expire? On average, most organizations probably have their passwords expire every 90 days. Some will be every 45 days. In very highly secured environments, you may have to change it every 15 to 30 days. It just depends. I've seen organizations where you have to, very high security, let's say government or military or whatever, you must change your password every 15 days, and you're not allowed to use the same password against multiple systems or multiple applications. So they actually have a tool that will detect whether or not that meets that particular requirement. But in general terms, and generally speaking, 90 days is probably the average and most likely good enough for most scenarios. You may also decide that you want to implement self-service password support, where you can have a user go in and reset their password if they forget it or if it gets locked out. This is different than having password changes that you would do because you've already got into your account. So the password reset would only be if you have forgotten your username, if you've forgotten your password And you have to click on the I've forgotten my password button, and then it takes you to the self-service tool. That's an optional configuration. It doesn't have to be enabled, but it's, it's depending upon the level of use of the level of experience of your users. You may decide to turn that on and save your help desk having to get 5,000 phone calls a day for people forgetting your passwords. The next one is AD identity protection. This is a tool or a set of tools that falls under Active Directory that helps to maintain identity, maintain what a person uses to connect to the system and the data that's associated with it. And of course, that works in conjunction with the password protection features, which again goes through with the complexities and expiration dates and so forth. The smart lockout is a functionality of the system that will help to basically maintain the system stability by automatically locking out suspicious activities. This could be multiple login attempts. This could be type of spamming, that sort of thing. Then we also have application proxies, single sign-on capabilities to be able to join other systems using whether they're SaaS-based solutions or on-prem solutions or a hybrid solution. Azure AD Connect to connect your on-premise Active Directory infrastructure to your cloud-based infrastructure so that you can synchronize your user accounts. And MFA and conditional access. So MFA, multi-factor authentication, is generally the use of an application. In the Microsoft world, it's the Microsoft Authenticator, which will then be used to, in one of three methods, either send you a text message, which you can then type the code in. You can have it go where you go into the applicator or into the authenticator and have to type the code that it generates into the system, or you could have it done where you get a notification pop up on your device and you just say approve, and then you can have it approved. Just as a side note for that, multiple organizations support MFA. Google does, Microsoft does, probably all your banks do, those sorts of things. When you're going to be getting and setting up your MFA, it's best practice to not use the text method, right? Because text messages can be spoofed, and so you may accidentally type in something that you didn't actually want to get or for some other reason. So your best option, especially on the Microsoft side, is to use the Authenticator app to generate either the single use code or to have it automatically approve the connection based on the application pop-up. So that's sort of the 70,000 foot view of how protection works in the environment. But the primary basis that this is all built on is the concept of something called zero trust. Right? Zero trust means that I always need to verify, the least principal access is given, and I'm going to assume that there's some sort of breach. Okay. So the zero trust methodology means I trust no one. Now, that might sound a bit harsh, but that's sort of the realities that we live in today. So for those of you that have been in IT for a few years, and I've been in it for this is going on my 34th year. I started when I was 17. At one point in time, if you were a Windows NT4 administrator, the concept is that we pretty much will install it with everything open, and then we'll lock down what we need to, right? Well, that worked okay for a while, and then of course the internet came along, and we have to worry about people hacking in and doing all sorts of nefarious stuff. So then we said, okay, well, we can't do that anymore. So then when Windows Server 2000 came around, we completely flipped it the opposite direction. We locked everything down, and then it was up to you to unlock what needed to have access to. And that's the idea of zero trust. So with zero trust, we need to verify explicitly who can connect to what, right? So I can't just log on to the system and go and connect to something, and whether I have access to or should have access to it or not, this is preventing me from getting there unless I explicitly have access to it. It also is working on the idea of, as I said, least privileged access. Okay, Now, let's say that you are running a help desk, and you have a number of users that are going to be working on your help desk, and you want to specifically assign certain tasks to specific help desk people, and that's the only thing that they're allowed to do. So let's say that you're a company the size of General Electric, as an example, right? They've got hundreds of thousands of users around the world. Probably at any given time, let's say 30,000 of them forget their password. So, they're going to call the help desk and help get their passwords reset. So you have a group of people whose job it is only to help people reset their passwords. You don't want them to be able to go in and do server administration or database administration and that sort of thing. And so if we just give them this, server admin rights to a server to be able to change passwords, they have way more capabilities to do things than what we really want them to do. And so that does not follow the idea of least privilege. So what we would do with Zero Trust is that we would create a customized role that would give them only the capability to change passwords, and we would assign those users to that security role, and then we don't have to worry about them having access to stuff that they don't need to. The next thing is assume breaches. Now, let's assume that everybody is out to get you. Right? There's a funny joke that says you don't have to be paranoid to know that there are people out to get you. And so system administrators and security administrators have to sort of follow the same idea, where we will assume that at some point in time, somewhere along the line, we will get breached, whether it's through ransomware or it could be as simple as somebody sat down and clicked on a file folder that they shouldn't have had access to, but they got into it anyways, right? I'll give you an example. Government of Canada, the Canadian Revenue Agency, has active monitoring on all of their networks, so that if you're an ordinary employee of the tax department and you try and log into somebody's tax return through their system, they will know instantly that this access has been attempted and this person doesn't have access to it, and they will literally have somebody come to them at their desk within a few minutes and ask them why they were trying to get in there. And if they don't have a valid reason, they will be instantaneously removed from their job and put on administrative restrictions, so that they can do an investigation to find out why you were trying to insert yourself into a tax return or whatever else. Because if you don't have access to it, you're not allowed to have access to it at all through the system. But you have to assume that not all breaches are going to be from hackers or people that live outside of your organization. A lot of times people internally will also try to get into stuff just because they try to, they're bored, whatever. And so sometimes your own users can be your own worst enemy. So what are the 6 pillars that make up the idea of the Zero Trust mentality? Okay. First of all is identity. And identities can be a number of different things. It could be users, it could be services, it could be devices. So as everybody knows, there's these things called CAPTCHAs. And they ask you to identify pictures to prove that you're not a robot, which I still think is quite humorous. But I guess a robot can't tell the difference between a bunny rabbit and a cat. So who knows? And so you may implement that sort of identity add-on so that they can prove who they are. But the identities are generally who is trying to get to something, right? So whether it's a device, your cell phone, your tablet, it's a service. Maybe you're trying to connect through VPN connection or VPN tunnel. And of course, who you are, that you're a user that says you are actually who you say you are as a user. Devices, obviously with devices, these have much larger attack surfaces. And the reason is because, of course, the device is going to be getting traffic associated to it from all sorts of different directions in all sorts of areas. And, the device, therefore, has this footprint that is much bigger than an individual user in terms of the potential for being attacked or gained access to. Applications, obviously this is how the application data or that data in general is consumed. And so you need to secure the application, make sure that it is secure tight. Applications are generally written around two philosophies. One is called OWASP, which is an open source secure protocol structure for software development. And the other one is basically the simple version of it is oh, I forgot what it was. Designed by secure by design. Sorry, brain freeze there. Was secure by design. So what you're doing is you're writing your code in such a way that you know it's secure. You're testing it against different security functionality that you can use, and making sure that the code is sound, doesn't have any bugs in it, that sort of stuff. Data, obviously, the data is the big one. That's what everybody's really after if they are trying to get into your system. And the important thing about data is that you do need to classify it. You should label it, and you should encrypt it based on a specific set of entities and attributes that are associated to that data, right? Far too often you have situations where people just go and store data in data files or data folders or something like that, and you never really know where it is because it's not classified, it's not easy to find. If you're a SharePoint user, you'll know that in SharePoint there is the capability of associating classifications or labels to that data or metadata to that data so that you can find it from search fields and organize it correctly. You could do the same thing at the file system level with all of your normal data, and that's how that's the proper way, the proper methodology for data to be stored. If you do this classification process and label it correctly, then it is much more secure because you have an idea of where it's supposed to live within your environments. Your infrastructure. So infrastructure is an interesting one. If the infrastructure is on-premise, then obviously you are 100% responsible for how you secure it, right? You're responsible for securing the building. You're responsible for securing the physical location of the data. You're responsible for the hardware that the data is running on. You're also responsible for any networking and internet connections that might be required for it. And so ultimately, you have to be completely responsible and know what all the different threat actors are and the different threat vectors that you'll need to protect against. And so it's all on you, okay? So I used to work at an international airport, and international airports are usually important places because hackers will try and steal all sorts of information, and so we constantly have to, be vigilant about, who can do what and how data is accessed and all that sort of stuff. And several times we've had situations where hackers would literally go and create domains. They would buy a domain name that was almost identical to the airport's domain name. And of course, the directors and senior management's names are listed on the website. And so they would send, emails out to say, oh, hey, I'm, so-and-so, I need to do this, and can you write this up really quickly, and so on. There was a situation where they got an email from an airline that said, we've changed our, we need this payment. You guys didn't pay us last month because they get a discount on their landing fees. Can you send us, this amount of money, but we need you to send it to us in yen. Well, that bank that airline deals with doesn't deal in yen, it deals in American dollars. So instantly the auditors, the processors went, hey, wait a minute, why am I sending this to you in yen? And then they stopped and they took a look at it and they realized, oh, hey, this is not real. This is from some other person, whatever else. Same thing happened in Norway a couple of years ago. There was the VP of finance was sent an email from the president of the company saying we just signed an agreement with this other company. We're going to do a company share, blah blah blah. We need to send them a check for 700,000 euros so that we could get this initiated and off the ground. Well, the finance director didn't actually bother to check by calling the CEO to make sure that that was right, because that's a very large amount of money. So he sent a wire transfer with 700,000 euros to this bank account and never saw it again. And 2 months later, that VP, after being put on suspension, was fired for lack of diligence. So that's an example of how all of the data and everything else that you need to work with needs to be secured. If you're in a cloud-based environment for infrastructure, then the physical components of the security are no longer your responsibility. They're now the responsibility of the cloud hoster, in this case, Microsoft. So they will be responsible for managing all of the infrastructure-related parts around security. And then last work, networking. Networking should be segmented. Even in a physical environments, if you're working with networks, you should virtualize some of the things. You should have VLANs created. You should separate the traffic for the desktop systems off of the traffic for the server systems, and then segregate your SAN off of to another one. And by doing this, it makes it more difficult for hackers and attackers to be able to get through. If they do get through the initial layer of security, then trying to figure out where everything else is once they're in makes it much more difficult that way. Okay. The next thing is this idea of defense in depth. Okay, so defense in depth is the idea of using a layered approach to security. So if we look at the chart on the left-hand side, or on the right-hand side rather, we see how we can secure our environments using different types of layers of information and different layers of technology to do it. The first layer outside is the physical security. So again, this is where you're talking about your buildings, your access to server rooms, and designs of the system and all those sorts of things. So how the access to the actual data center is given to authorized personnel. I was as an application administrator, I should never have physical access to a data center. I don't need physical access to a data center as an application administrator. I need remote access to the servers that I communicate with, and that's it. Maybe in an emergency, if I'm the only person around, I would get temporary access to the data center, but that should never as a normal thing be. And I look at it this way, that if I'm not capable of getting into the server room, if something breaks, then I can't be responsible for it. So it brings up that level of authority and capabilities that would be associated to me. That level of plausible deniability, I guess, is the term I'm looking for. Although there are examples of physical design that are important. If we're looking at on-premise versus the cloud, I've been in situations before where I've done security audits for organizations, and as part of the physical security audit, I'm wandering around looking at the building and looking at things like locks and secure codes and that sort of thing. And I did one time at a chemical company who was quite certain that their server room, their data center, was very, very secure. The server administrator, the domain administrator was quite proud of the room that they had built to put all the data in. It had reverse compression and all that sort of fun stuff, and physical identity locks on the doors, and scan cards and fingerprint readers and all that sort of fun stuff. And as we're wandering around, I'm looking at the room, and we're out in the hallway. We haven't actually gotten in the room yet. And I said to the guy, I said, I'll bet you lunch that I can be in your server room in 15 minutes. And he kind of looked at me. He's like, yeah, whatever. And I said, no, seriously. He goes, okay, fine. Lunch is on me if you're in there. I said, okay. He says, I'm going to go get coffee. I'll be back. I'll see you right here. I said, okay, fine. So he comes back, and I'm not in the hallway. And he opens the door to the server room, and I'm sitting at the server console waiting for him. And he's looking at me, he's like, how did you get in here? Like, I don't understand. Like, we've got all these different things in the door. How did you get in here? I said, look up. And he looked up. And in that building, they had suspended ceilings. So the walls didn't go all the way to the roof. So I basically just crawled through the suspended ceiling and came into the server room. And he was very upset because they had spent so much money to build this thing. And then when the builders came in, they didn't actually do it properly. They didn't put the tops of the walls in. They only built to where the suspended ceiling would go, which is how all the other offices in the building were built. So, so there's things like that are important. Now, when you're working in a cloud environment, obviously, you don't have access to the building, so you don't have to worry about that. But if you're going to a facility that Microsoft owns as a data center, first of all, nobody really knows where it is because it's not advertised. And then there's security, there's fencing around it, there's 24-hour security guards and data center managers and all that sort of stuff that would be working at the facility. Physical security obviously is limited, and you want to make sure that amount of access is given to only those that are going to need access to the data center, and that would be just to the personnel that are going to need it. Identity control or identity access, and security, controlling access to infrastructure and changing control. Right, so this is where you're going to bring into the mix about who the users are, what they have access to, how long they have access to it, and so forth. Some organizations will have very secure data, and they will restrict access to specific parts of the system in a certain time frame. So even as an administrator, if you try to connect in after, let's say, 6 p.m., when everybody's going home, you'll get rejected access to it because the access hours are not granted to you. And so this is how we can use identity management and identity control to access who can get into the infrastructure and make changes and so forth. So the important thing about that is of course, that knowing who you are and what your role is in terms of being able to get into the system and the amount of access that you have. That's all really important. The next is perimeter security. So that's the next layer down. You'll notice that as we go through these, they're getting closer and closer to the actual data that we're working on. So perimeter security is giving us the capability of preventing things like denial of service attacks, filtering against denial of service for users, right? So there are a number of features that we can use to implement that. In the Microsoft world, on the out-facing network infrastructure, there is the capability of blocking network traffic that looks like it's being flooded, like large-scale pings as an example. And that's generally one of the ways that denial of service attacks occurred, is that several thousand computers will be constantly sending ping requests to the DNS server of the destination network, which then it will not be able to answer any requests for data from any other normal valid user. And so by using that prevention tool, we can help to prevent those sorts of things. There are other tools as well. There are different websites that you can put in front of your destination website. Cloudflare is one of them as an example, where it will look at your incoming IP address and sort of what the traffic request is, and determine whether or not it's a DDoS type of attack, and then will reject you or accept you based on what it finds as part of that connection. I actually once found out that my computer had been compromised, not because I had found a whole bunch of information or traffic or any of that sort of stuff, but because I went to go log into a website one day, and one of these intrusion detectors popped up and looked at my traffic and rejected my access because it says that I was participating in a denial of service attack. And I'm like, well, that doesn't make any sense. So then I started to root around my computer and realized that there was a whole hidden directory on my C drive that it had spam email server running on it, and it was basically sending spam messages out to the world. And I obviously had to put it into that and then solve that problem. But those types of things can happen quite easily. The average daily user who doesn't understand technology really well may or may not get a situation like this, and so that can happen. And so by putting these types of prevention tools in place will help to protect your network from those types of attacks. The next one is the network security. Okay, so this can limit who can access what traffic where and when. And it uses segregation and access controls to determine what the data or who can access that data. And so by using the different layers of traffic and segregating the traffic to different types of things, again, you can restrict how computers or how individuals can communicate with systems and prevent them from being able to nefariously access the data. So basically the first 1, 2, 3, 4, 5 layers up to this one, which is compute, are managed generally by Microsoft. Okay, depending upon how you've implemented your application, we'll take a look at that in a minute. Most of this is going to be done by your cloud hoster, so you as an individual don't have to worry about this. The compute layer is where you're going to give access to the virtual machines and to the virtual environments. Most 99.2% of people, when they're running applications or using a tool, don't need access to an actual virtual machine that hosts the application. Only the server levels and the application level people need to have that access. And so the compute layer will give you and determine who can access those virtual machines and where that traffic can originate from. And again, this doesn't matter whether it's on-premise or in the cloud. And you would use things like port management and application hardening and that sort of stuff to make sure that you can really make sure that the systems are secured. So the next two are generally on the end user or the organization that's actually running the application. So the first one is the application layer, where we will secure all of the applications internally. Okay, so this could be either through security policies that you set up in the application, or using the OWASP secure by design principles that you would use to build the application itself. So if we're doing, as an example, an in-house built application that you have your own developers and they're writing the software, you'll need to make sure, obviously, that as a developer, that you are developing secure code, that you're not leaving any bugs there that could potentially be compromised, that you're using the most up-to-date resource libraries and whatnot. We read in the news all the time of situations that people have used different components, whether they've purchased or open source or what have you, that have subsequently been found to have bugs in them. So the latest one is the logger tool. I think it's called 4logger, where it was discovered that it's a Java library that has some pretty big bugs in it that have been compromised by hackers. And so there's been a rush to A, fix it, and then B, get it deployed to a number of applications that you've built it to. And so those examples like that of where you need to be careful. If you're using an application that you purchased, let's say Dynamics 365 Finance and Operations, which is where I spend a good chunk of my life, there are different layers and different methods of securing that software. We're relying on the software vendor to make sure that the application is free of bugs and patches and free of bugs and vulnerabilities and so forth. And so, as from a security point of view, we're going to be responsible for maintaining the user account information within the application. So in Dynamics, as an example, you set up user roles, and those user roles have specific permissions, and those permissions have privileges, and then that's what the user can do. And so you, as an administrator, will be responsible for making sure that those are configured and set up correctly. So depending, again, where that application is coming from will determine how much of the effort is on you and how much of that effort is on somebody else. The last one is the data layer. Well, this is the closest to where the most important thing out of all of this lives, your data, right? You cannot function without your data. And so the security controls around the data determine what business tools, what user applications and users can access customer data within a system. This may or may not include encrypted data, although it is strongly recommended that, at least for when data is in rest, that you encrypt the data for storage. And then if you need to transfer it to someplace else, you can decrypt the data. Also, it's best that you use protocols like TLS to transmit data as a secure method as well, using SSL certificates and so forth. But securing the data is, as I said, is probably the most important thing, because this is where the money that your company makes comes from. And I've always said for a lot of years that if you could figure out how to break into something like an Iron Mountain or one of the other large offsite storage locations, if you could figure out how to break into those and steal the information from them, that it would be far better and more profitable than if you were trying to rob a bank. Because you can use that data to either blackmail a company, or if it's a publicly traded company, to manipulate the stock, and so on and so forth. So the amount of data and security control around that data is vital. Hopefully I haven't scared anybody yet. All right, the next thing is confidentiality, integrity, and availability, or it's also known as CIA. So CIA is a way for us to think about the security trade-offs. So if we look at the three layers that make up the CIA, so confidentiality basically means who needs to see something and how are we going to secure that information, right? So as an example, I am a AP clerk in the finance department. My job is to process invoices that come in from vendors and get them paid, okay? That's really all I do every day. I don't do anything else. Do I, as that type of user, need to see the financial statement that the company produces every month? Or do I need to be able to see the information on a particular vendor when I'm processing their vendor account, their vendor invoice? Do I need to see the bank account information for that vendor based on that vendor's information? You need to determine, based on those types of questions, what does and doesn't that individual need to do and see, and then figure out how you're going to secure around that, okay? So the confidentiality is important. You don't want everybody being able to log in and look at everybody's payroll if the human resources folder for payroll is, basically left with everyone full access. And so there does need an inordinate amount of time to look at security. And security is never done. It is one of those things in an organization, whether it's an internal application or it's a purchase-based application, you will constantly be tweaking the security to make it better and stronger as you go through the life cycle of the application. The next thing is integrity. This is making sure that the data and the messages and the data that's in the messages is correct, right? So if I'm spoofing something, I'm basically interfering with the message, re-changing or redoing or changing something that's in that message, and then sending it back out, even though it was me that changed it, but the user on the receiver side doesn't understand that or doesn't know that. As an example, if you get an email and it's been compromised and something's changed in the middle, unless you know how to look at the header information and understand what server names are and IP addresses and all that sort of fun stuff, DNS servers and routes are, you wouldn't have an idea, right? But you might click on a link in an email and it takes you to a website that looks like Bank of America's website, and you type in all your credential information, and it says, oh, I'm sorry, could you retype that, please? We didn't get it. And you retype it, and it comes up and it says, oh, we're having server errors in the moment, come back later. Well, by that point in time, you've given your username and password to hackers, and they can now go in and clean out your bank account. So being able to understand and knowing whether or not the data that is in a particular message it has integrity or not is very important. I'm going to admit to something that I shouldn't, but the other day I was really busy at work, and I had been having issues with my passwords for one of my secure networks, and couldn't figure out why I couldn't get logged in. So I tried a couple things, and then I just put it aside. And then I got an email a little bit later in the day saying, "Oh, we think we've sorted it out. If you click here, you can go back in and update your web password and that sort of stuff." And I wasn't even really reading the message. I just saw it says button, press reset, and I went, "Oh, okay." And I clicked the reset button, and of course it took me to haha, you've been caught in a phishing scam, blah blah blah. Now you have to go and take a security class for an hour and then pass a quiz, and then we'll give you access rights again. And I just sat there and I went, oh God, this is what I tell people to do for a living, and I just did it myself. So it's not hard to get caught up and spoofed on any of those situations. The third pillar is availability. Now, again, availability could be the time frame in terms of the number of hours in the day that it needs to be available, or it could be for who needs to access it. And again, you don't, just because you work in an organization doesn't mean that you should have access to everything in the organization. You need to be able to have requirements around who can access what types of data to make sure that it's secure and used properly. Again, you wouldn't want Joe Schmo in the maintenance department looking at last month's financial statements, and then be out at the pub one night having a few pints and telling friends about how much money the company's lost, with somebody who's listening in the background going, "Oh, really? They've lost that much money? Maybe I should dump their stock and the stock price drops." Just goofy things like that. But you never know, and so it's best that you set up to make sure that those sorts of situations and those individuals who don't need access to stuff don't get it. And it just makes it easier that way to make sure that everything is secure. Okay, so who's responsible? Well, as I mentioned previously, this is a shared responsibility. So the responsibility of managing it is determined by what level of infrastructure you've purchased and what you're working on. So the three primary cloud-based infrastructures are SaaS, service as a solution, or SaaS, software as a solution, PaaS, which is platform as a service, and IaaS, which is infrastructure as a service. Those are the three cloud-based infrastructure types, and of course, those are your on-prem network. And depending upon how you've got your network set up will determine at what layer who is responsible for what. So this chart actually breaks it down quite simply in terms of how the networks are split out and who is responsible for those types of information. Right? So if we're looking at we'll start on the right-hand side and move our way left. But if we started as an on-premise network, as I mentioned previously, you're responsible for the whole thing. The data, the infrastructure, the systems, the network, the user access, you are responsible for all of it. So if somebody breaks in and steals something, ultimately it's on your guys' head. Internally, you can't blame anybody else for that data breach and what's been missing. Now, there's a couple of ways. There's a couple of ways that you can use to help with that. And there's also, obviously making sure that you have physical infrastructure in place and you have proper cooling and heating and air compression and all that sort of stuff there, so that you can always be responsible for what the customers are going to see. You all will also be responsible for the types of data and the services that are appropriate for that type of data. And then also you are responsible for the transfer of that data to internal and or cloud providers. Right? You are also responsible for maintaining integrity, which also means things like backups and those sorts of things. There is no worse feeling in the world when you need to go and restore something from a tape backup to find out that the backups haven't been working for months because you haven't taken the time to actually go back and validate that the backups are valid and actually working. I've been in that situation a couple of times where I worked for an organization that they had their sand crashed. They had two different types of sands, and they're out of lifespan, and they crashed and whatever. And so like, okay, well, they went back to their tapes and found out that the backups had not actually been successful for the previous 2 years. And so they had no data available for them to be able to restore. And so they were, luckily, one of the two sands actually still had a backup copy of the information on it, but the actual tape backup system that they were using had failed, and it was not recording anything. And the problem is that the organization was short-staffed in terms of the IT department, and they didn't actually have a person who was responsible for maintaining the backups. And so nobody was actually checking. Everybody assumed that somebody else was doing it, but nobody actually checked to make sure that it was being completed. And so far, they didn't have any data. So there was a rather large sigh of relief that they at least discovered that, but it could have been even more catastrophically failure if they had absolutely nothing. So what they ended up doing is that they scrapped the tape system and they put it into a secondary site. And so they had two live data centers running at all times. One was the active one, the other the passive one, but at least they had the data in two places. And so that's a situation where you run into that quite often, where people don't realize that the data that they thought that was being backed up wasn't. On the infrastructure as a service, you'll see here that Microsoft is now starting to get involved in the security model, and they're responsible for the physical hosts, the physical network, and the physical data center. Because you don't actually have access to them, you can't be held responsible for making sure that they're secured and up to date and everything is working properly. And so that's the that's the responsibility of Microsoft. Everything else, everything from the service types, from the operating system all the way up to the information and data, is still the responsibility of the customer. If we move over one to platform as a service, now again we're getting more into the Microsoft managed thing, where we're looking at everything up to the operating system being managed by Microsoft. And the three layers for identity, infrastructure, application, and networking is sort of a 50-50 role between you and Microsoft. Microsoft will comply and secure a portion of it, and then you are responsible for the rest. And then lastly, a service is a solution where Microsoft is responsible pretty much for everything up into account management, at which point you as an individual organization are responsible for that. So that would be where you're looking at things like, let's say CRM or finance and operations, that sort of stuff. Microsoft is responsible for everything up to the application layer. So monthly patching, hot fixes, all that sort of stuff, infrastructure availability, uptime, the whole deal. And you're only responsible for the actual use of the data, the devices that can access the data, and the information, the data itself, right? And of course, as part of this is that you have a written agreement between yourself and Microsoft that they are not going to encroach into your area, meaning that they're not going to just go in and take a look at your data, or they're going to go in and take a look at how you set up your security policy and security rules, unless it has a negative impact on the other users in Azure or in Dynamics, because it's all shared infrastructure. So as long as you're not doing something that causes anybody else to break, then you're pretty much fair game. So threats. Where are the threats coming from? Usually, the threats are either through a data breach, where we'll have tech support scams, SQL injections, malware designed to steal passwords and details from the bank, or a phishing exercise. I sort of gave you the example of the phishing exercise at the airport where somebody had basically gone through the hassle of making another company look like the airport and send it out to try and get payment for it. Malware, I mean, everybody knows what malware is. I mean, anybody who's not gotten malware yet obviously has never been on the internet. Um, I've set up new email accounts. So as part of training, one of the things that we have to do is that when we go to use one of the Azure passes for Azure Access for the training course, we have to create a temporary email. It's usually like an Outlook email or something like that. So I tend to use this. Like my nickname is the Tatted Geek, and so I will create an email address around that, and then at Outlook.com, and then I can register my Azure Pass to that. But a lot of times I will go and I'll create that account, and within, I kid you not, within an hour, I am already starting to get spam email, right? And so it doesn't take long for those sorts of things to occur. And this included things like the malware designed to steal your passwords and stuff. I used the example of, you get an email from your bank saying, "Oh, there's been an accident. We need you to log in." Blah blah blah. Banks will tell you all the time, "We'll never do that. We'll never ever, send you a request for your password and that's the rest of it." But the problem is that most people who are caught by those scenarios are not technically savvy, are not paying attention, and they're the easy targets. And unfortunately, generally, those easy targets are old people, and because they don't understand it, they don't know what to do. The technical support scam one is funny. I don't know about. So originally, I'm from Canada. I moved here in last March, and there was this thing going around for quite a while that we would be getting. And this happened to my mom, and it was quite funny actually. She got a phone call one day from Windows. "Hello, this is Windows calling. We'd just like to let you know that your computer is shedding your personal information out onto the internet as we speak." And my mom's like, "What?" And they're like, "Yes, your computer is sending information out onto the internet." And she goes, I don't have a computer. I have a tablet." "Oh no, ma'am. I can see it clearly right here that your computer is sending this information out." And she's like, "Okay, hang on a second." So she put this person on hold and she called me on her cell phone. She said, "I got this phone call from this guy and blah, blah, blah." And I said, "Tell him to bleep off and hang up on him." And she's like, "What?" I said, "Just do it." So she's like, "Okay, fine." And about 3 days later, there's another phone call. They called again. And she's like, "Screw off, whatever." And of course, what was happening is that they were never calling from the same number. They would use a phone device to call from different locations. And try and get that. And you could always tell that you knew that the gig was up, because they would want, payment in iPhone cards or, gift cards or shit like that instead of your regular bank account or your credit card or whatever like that. So that went on for, oh God, almost a year. She would get maybe 1 or twice a month, 3 times a month. She'd get these phone calls from Windows calling. And the one time that they called, they happened to call at Christmas time when I was home visiting. And I had great fun with that, because what I ended up doing was, knowing that they were not the sharpest knives in the drawer either, I set up a Linux box that I then put into an area. And so when they called, I said, "Oh, that's very serious. We better fix that." And so I said, "Well, can you help me? Can you remote into my computer?" "Oh, yes, we can do that. We can help you with that. No problem." I said, "Okay, great. Here's my IP address, blah, blah, blah." And they're like, "Okay, I can't seem to connect to this computer." I said, "Well, this is a Linux computer. You said it's my computer. It's the only computer I have." "Oh, well, let me try this." And in the meantime, while they were doing that, I had a Wireshark running in the background, so I could detect where their IP address was and where they were coming from. And I kept them on the phone long enough where I could basically reverse connect. And they were running Windows and they didn't have any security on it. And I said, "By the way, is your mouse moving?" And the person's like, "What's going on?" I said, "That's me controlling your computer. Now don't ever phone here again." And I hung up on them, and they never did. So it was just one of those things where, and then we've had other ones where people are trying to steal social insurance number information, and they tell you that your social insurance number has been hacked, and you would have an arrest warrant out for you, all sorts of stuff like that. When I got the arrest warrant one, I actually called the RC. I pressed 1 and I waited for a person. And when the person picked up, I said, just so you know, I live across the street from the RCMP office. Would it be just easier if I walk over and turn myself in instead of you coming to arrest me? And she hung up on me. So it's like, okay, fine. So those are scenarios where you could, from a data breach point of view, and things that can happen. Dictionary attack. These are old as the hills, but this is why we tell people that when they create their passwords that they have to have an alphanumeric character and a non-alphanumeric character and a capital letter and a small letter and that sort of stuff, so that these dictionary attack schemes don't work as well as they would have at certain times in life. The problem is then, again, if you have non-technical people or non-tech savvy people, and you say to them, look, you've got to have X, Y, and Z in your password to make it secure, they're like, well, why? I will never remember that. And inevitably, they'll put it in thinking that they're, oh, this is really good. And then they'll not remember it an hour later. And so they'll have to reset it again, right? So the dictionary attacks work really, really well against those types of people because they don't know how to set up their system and secure it correctly. And so the dictionary attack will basically just have a dictionary full of words, and we'll just randomly choose the words until it finds one that it can use to get into the system. Now, to prevent dictionary attacks, the simplest thing you can do is disable after a number of incorrect logins. So by default, Windows has, if you try 3 times, you don't get your password logged in 3 times properly, it locks your account out. But the problem is that in 30 minutes, by default, it will unlock your account and let you try in again. But in the meantime, the dictionary attacker is still trying to figure out what the password is by sending different passwords and going in and through. And this type of brute force attack still happens. It's not usually very successful, but it can happen, and it does work on enough times to keep trying it. Ransomware, that's the biggie these days. People being, caught by different organizations, usually, scamming organizations, or in this case, certain countries. There was another one that happened just recently to the Ukraine, and we can pretty much probably figure out, if we think about it for 10 seconds, what country that came from. And so this is basically just a type of malware that will encrypt your file and folders and basically extort money from you in some form or another. I know, like, for instance, the council that I live in, the borough that I live in London is called Hackney. The council got hacked, which is quite ironic. I find it. Hackney got hacked in October of 2020. And they're just now starting to get their systems back online because they didn't want to pay the ransomware, of course. The NHS has been attacked. There's been several large companies. There was the meat packing company in the US that got attacked, and so forth. And there becomes a bit of a philosophical argument about whether or not you pay them and get the encryption key or the decryption key so you can get your data back. The problem then becomes is that once you've done that the first time, chances are you haven't really done anything to mitigate that. And so they will try a second time or a third time and be successful. The other option is to say, no, screw you, we're not paying for it. Now, if you have proper backups and offline storage and all that stuff of all your data, then you may lose a small proportion of your data, but you can at least get the majority of it back. And so you can restore that information and not pay the ransom and carry on with your business. But then, of course, you have to go through and properly secure your system. 9 times out of 10, ransomware attacks come from either opening up an attachment in an email message or clicking on specific websites that load applications in the background through cookies, right? So when the idea of ransomware first came out, maybe 10 years ago or so, generally what it was is that if a person was trying to go out and connect to the internet, they would get a pop-up on they would take over the web browser. And they wouldn't lock their files or anything at that point yet. They hadn't figured out the encryption part. It was just a matter of, taking over a person's session. So a friend of mine actually who who is a police officer in Canada, called me one day and he's like, "Can you come over to my house? I think there's a problem with my computer." And what happened was that he got a pop up in great big red box saying, the RCMP has detected that you've been trafficking, you've been looking at illegal websites and blah 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 blah. Which, first of all, the RCMP doesn't monitor everybody's traffic on the internet. That's something that they do in other countries, but they've got much better things to do with their time. So it's just a matter of figuring out what web page or what file internally they had dropped down through the cookie, deleting that, resetting their password, or resetting their pages in the browser, in this case is Internet Explorer, and they were back to normal and everything was good. The next iteration of that, of course, was when the file encryption and whatnot took place. And so so if you remember Lovebug, the virus Lovebug, the love bug was when you would click on a message in an email that said, go see Doug's message, and it said, "I love you," and you click on it and it would encrypt the mail server and you'd be stuck, or your file server, and you wouldn't know what to do with it. So I've had a couple of situations with those ones where people have actually had to rebuild their entire mail infrastructure, because it literally ate the mail server because of too many people clicking on "I love you." The last one is a disruptive attack. Again, this could be a DDoS attack. This could be a number of ways to basically block legitimate traffic from being able to get into your network. And these are targeted, at, as I said, at the endpoints, so generally at the DNS server or at your router. And so we need to make sure that we have systems in place to prevent those sorts of things from occurring. Again, as I said, in Azure, there is an actual DDoS tool that's built into the networking infrastructure so that you can prevent those sorts of attacks and people being able to to bring your network down. There's other applications that you can purchase, such as, I say, Cloudflare and some of those other ones that will do the detection before it gets to your web page, and it makes it that much more secure and valid that the data that you're getting through is going to be of non-threatening packets and data and that sort of thing. There's all sorts of other things that are included in common threats. The latest one that seems to be very popular is this idea of coin miners. I have been in IT, as I said, for 34 years, and I still do not understand the whole fascination and rage of cryptocurrency. I don't believe in it. I don't trust it. I don't think it's going to last forever. I don't particularly like a technology that somebody could start an application and go and mine for something that doesn't physically exist. And so these coin miners and all these sorts of things where they're mining for Bitcoins and stuff, I don't understand it. I don't think it makes any sense, but whatever. But these sorts of things can, impact how your applications run in your organization. Rootkits. Rootkits are quite nasty because, of course, not only does it affect the software of what it is that you're trying to do, it also impacts the application, or sorry, the hardware of the computer. So you might have rootkit viruses that will get in and affect the BIOS on your desktop, and every time your desktop opens, even though you've done a virus scrub, it reruns that virus execution and it takes advantage of your system. So that's one that's particularly nasty. Trojans, worms, those sorts of things, they've been around for quite a while. Most of the antivirus, anti-malware tools that are available tend to do a really good job of making sure that those sorts of things are not affecting you. And exploit kits. Again, these are things that are generally sent through documents. Macros, as an example, there was a big thing for quite a while of sending problems through email macros, through Excel or Word macros or PDF macros, and yeah, it's amazing that some of these things can still be passed around, and people will still fall for them. But again, if you're not very technical savvy, then it's hard to secure stuff. The common thread amongst all of these is the best way to prevent all of them is through knowledge and through education. whether that is taking a technical class as a security administrator, or as simple as educating your end users on common security principles. Every organization that I've worked for in the last 10 years have all had mandatory desktop security training. And so at the airport, as an example, every month you would have it would take about 20 minutes to complete, but it was a little course on things like USB security or phishing exercises or losing data in public or whatever. And then they would give you a little quiz at the end of it. If you pass the quiz, then you pass the training for that month. And then randomly, they would just send out an email that would be basically a phishing exercise to see who would fall for it. And then those people would need more remedial training around security and making sure that it would work. The funny part around that, though, is that we were doing those training sessions, and we brought in a new firewall that had link detection in it. So when an email would come in, it would go and look at a link, and it would determine whether it was valid or not. And anyways, so, because the emails were coming from a generic email address, the firewall kept blocking it at the mail server. And so people weren't getting the phishing exercises. So it was a proof that the configuration that they had for the phishing server actually worked and was doing what it was supposed to do. Okay, so for encryption, if we look at the encryption capabilities, so encryption is obviously the process of making data unreadable and unusable to an unauthorized viewer. It scrambles it up. It basically gives you all sorts of wingback characters and things like that, so that you can't actually read the data. And there are two types of data encryption. There's data encryption at rest, where you are securing the data while it's stored on a server or in some sort of drive storage management. And then there's encryption of data in transit. You should implement both of those technologies. You should have information shared and secured at rest and at transport. So the two things that we would look at when we're talking about encryption at rest would be storing the data in a database or storing it where it's unreadable. So to be able to read the data, you would need a security key to unlock it, and then whatever the secret key is a key to lock it, and then whatever the secret key to unlock it, and then that would decrypt it so that you could view it. If we're using encryption of data in transit, we're using things like SSL, TLS, HTTPS, data signing, hashtagging, all those sorts of things to validate that the data that's being sent is A, secured, and B, is accurate when it's received at the receiving end, so that they know that it's actually valid and it hasn't been compromised or messed around with. And the two types of encryption that we have are symmetric, where we have the same key that we're going to be using to encrypt and decrypt the data pair. That works, but generally it's not the best if you're sending data to people outside of your organization, right? So if you are sending a file from user 1 to user 2 in your organization, because you're both connected to the same Active Directory infrastructure and the same key servers and so forth, using symmetric keys would be fine, because you're going to be able to get the key back and forth to you through the networking infrastructure. If you're sending to somebody that's external to your organization, you'll want to use an asymmetric key, which is using a public-private key pair, right? So the public key is used to, I always get this wrong. The public key is always used to lock the contents, and the private key is what is used to unlock it. So if you are sending to me, you would send it and you would use your public key to lock the file, and I would use my private key to unlock it. Now, how I'm getting that private key could be through a number of ways. It could be that I have to connect to a server that would give me a temporary access code and that sort of stuff. But basically, this asymmetric encryption is going to be using TLS, and I need to have at least part of the key to be able to unlock the file. If you lose the keys, then that becomes a bit of a problem, because you need to have somewhere in this process that you have stored the master backup of it. And luckily, in both on-prem and cloud-based solutions, there are key management servers that will control that. In Active Directory on-premise, it's called the certificate server. And the certificate server is what actually implements and issues the keys. And it keeps track of all of the public-private key pairs. So that if you lose your private key, or your public key for that matter, you'll be able to go to the key server and recover it. You could also then get it retired so that nobody could use that key pair again, and then it would issue a new set. If you're external and you're using Azure AD, there's something called the Azure Key Vault. The Key Vault works basically exactly the same way as the certificate server, in and of that it is responsible for managing and maintaining all of the security key pairs and so on. And so a security manager can go into the vault, recover the lost keys, or make them expired and then create new ones. But it's basically everything is stored into that vault section. All right. So the next thing is something called the Cloud Adoption Framework. The Cloud Adoption Framework has been defined based on cloud adaptation best practices. And it is used by Microsoft employees, customers, and partners or have been used by partners and customers and Microsoft people to create this structure and how to adopt the cloud and go from your on-premise infrastructure to the cloud. It is a consistent method. It is the same every single time, and it works exactly the way it's designed for implementing different technologies. And there is a number of different organizations and tried and true methods that have been tried to get this to work. And over the years, this has been refined down to make it a consistent and simple process that everybody can follow. So first of all, the Cloud Adoption Framework consists of documentation, implementation guidance, and best practices. So these sorts of things are going to be important for you, A, to understand, and B, to use so that you can have greater security compliance, greater data integrity, and much more efficient migrations. And so, of course, that's the important thing. You don't want to have to take 16 months to do a migration of a bit of data where people have to wait and get access to things and so forth. And also this process, this framework helps the business to implement whatever strategies they'll need to succeed in the cloud, whether it's going with SaaS-based solutions or infrastructure solutions or those sorts of things. And so they can figure out, what layer they'll be responsible for and what layer Microsoft is responsible for, and so on. And the lifecycle is consistent of 6 parts. So the first thing you need to do is you need to define your strategy. So this is where you're going to sit down and figure out, how am I going to actually do that? What have I got? Where does it live? And what do I expect to happen at the other end, right? So if you can't define what your outcomes are by the time you get to the end of this process, then you need to take a step back, look at what you're trying to do, and figure out what the outcome is, right? You need to have a goal in mind. You can't just say, well, we're going to do this and we'll get there when we get there. No, you need to know what the outcome is before you start the process. The second thing is plan. And I cannot emphasize this enough. Plan until you're tired of planning, and then plan some more, because you can never over-plan different scenarios, right? You'll get, I've seen it a number of times where they get started into it and they get partway through and they go, oh, gee, I never thought of that. Or, oh, that's not good. What do we do about this, right? I'll give you an example. This is many years ago, but migrating Exchange 5.5, yes, 5.5, to Exchange Online. So it's a rather ugly process, but it is doable. You have to do an intermediary step to an on-premise Exchange server, but you can do it. So anyways, so this company had Exchange 5.5, and they had 9 servers, and all of the servers had databases on them that were way too big for what the services could handle. And so they were going to do their migration, and they had to migrate from Exchange 5.5 to Exchange 2010, and then from 2010 they could go to Exchange Online. So I was working in the ecom group at the time as a consultant, and I said, well, has anybody actually checked the integrity of the databases on Exchange? And like all of these people are experienced Exchange administrators, and they all went, what's that? And I said, okay, well, we need to check to make sure that the databases themselves are have integrity so that we can migrate them over. Okay, so I put in for an outage and went and ran a bunch of commands, ESE util commands and so forth. Came back and found out, well, first of all, the databases only have, a quarter of the actual space that's allocated to the database files that has data in it. And a bunch of them are not valid because they have, invalid hooks and this and that and everything else. So the first thing we need to do is we need to truncate the database files and we need to fix the databases. Okay, fine. And I said, so we need outages and so on. And it took a few extra days before we could do that. And one of the project's managers got annoyed that this was taking too long and instructed one of the other project people to just go ahead and do one. So they took one of the Exchange servers and they did a migration to it, and it blew up. It lost all the data, all the rest of it, because the data in the physical infrastructure of the data file was not valid to be able to do the migration. And so without the planning that we did and without being prepared and being ready for it, if they would have just gone and done the migration from the database files that they had, they would have blown up the entire mail system and the whole thing would have been a complete failure. So, they were supporting a financial institution, and of course, email is their second most important application behind their banking tool. So we need to make sure that this is done properly. So plan. Make sure you're ready for the migration, right? Obviously, being ready is making sure that they're prepared, the cloud environment is paid for and organized and ready to actually accept information, and who's going to be doing what, who's got the global admin and enterprise admin and all that sort of stuff. And then you have to be ready to adopt. And there's 2 different steps for adoption. There's migration, where you're actually going to migrate and modernize all of your existing workloads to current technologies and infrastructure. Or there's innovate, where you're going to develop new cloud native and hybrid solutions so that you're starting completely from scratch. Everything is going to be new except for the data, or even maybe the data, but you're going to change how you're going to implement this. And then you need to govern, making sure that, once you've got everything in there, that the governance is working properly. And operations and management for cloud and hybrid solutions are the last thing. So define your strategy, plan, get it ready, do the adoption, make sure you have governance in place, and manage. All right, next. What are some of the common identity attacks that we have to deal with? So, I said this a few times already, but the biggest one that we're going to run into are phishing attacks or spear attacks. Okay. So let's take a look at, first of all, the password attacks. So password attacks generally are employing brute force technologies to gain unauthorized access to the system. And generally what happens is that they'll attempt to gain access by trying different username and password combinations. They'll try to find out, what the administrator's account is, because of course that account has the greatest level of permissions. And then once it can figure out the account name, then it can use an automated tool to try and guess the passwords and that sort of stuff. Also, sometimes attackers will upright and call you and say, what's the password? Like, oh, I'm from the admin group, I need to get into this. And depending upon, any person, they can be tired, whatever, they could just give it out, and away you go. But the password attacks that occur are generally because administrators leave things too obvious. So obviously in Windows and in Active Directory, the administrator's account is called administrator or admin. What more obvious account would there be to look for than administrator or admin? So change the name. Go in and change it to look like a normal user, right? And if you really want it to stand out, make it, because you're probably going to have hundreds of users in your user list. Make a user Robert De Niro and make that the administrator's account, or change the name of the administrator's account to be Barack Obama or something like that. Whatever it was, Boris Johnson, Tiny Tim, whatever you want it to be, but don't leave it as the administrator account name. Or the other thing you should do is that once you have your network up and running, disable the administrator's account and then give another user the permissions that the administrator's account would have. So make them enterprise admin. And then, that way, again, other users, if they're trying to log in through a hack or trying to do a brute force attack, they have no idea what the administrator's account is. So you've already set them back from that point of view. Some other variations of brute force attacks are something called a spray attack and a credential stuffing attack. Credential stuffing is when the attacker will take advantage of the fact that most people use the same username and passwords across many sites. And so, if you use the same password across different sites for things like stolen credit cards and data breaches and that sort of stuff, chances are you're going to use it in other places. So if they got your username and password from, British Airways got attacked here a while ago. So if they got into the British Airways database, they could probably figure out, oh, Brent goes to Amazon, and Brent goes to Microsoft, and Brent goes to Next.com, and Brent goes to Asda.com. How much do you want to bet he uses the same username and password for all those? Hey, look at that, he does. Not that I do, but I also have a password manager so that you don't. That's another thing I'll talk to in a second here. But anyway, so they kind of use a little bit of smarts and say, oh well, if they use this one, the chances are they use it in a different one. With a password spray, a password will typically spray a commonly used password against many different accounts. So try not to use the same password against all of your accounts. It makes the problem with that, of course, is that it means you have a lot of passwords. So you have to have some place to actually keep them. So there are a number of secure tools out there called password managers. Now, I use one. I pay a subscription for it every year. It's quite nice. It's a SaaS-based solution. I can use it on as many computers as I want. And the nice thing about that is that if somebody for whatever reason has gotten a keylogger onto your computer, a keylogger is basically just a little tool that runs in the background that has an internet connection that monitors all your keystrokes and then records them and then sends them back to someplace else. If you have a password app, a password tool, when you're entering your password into the screen, it doesn't type the password in. It types the password in, but it's like a copy paste. You don't actually type with your keyboard. So there's no way for the keyloggers to be able to identify the characters that you're typing into the password field. And I quite like that. I have probably 300 or 400 different sites that I have passwords for. And so I use the password tool, and it's great because it works on my cell phone, it works on my desktop, and it keeps everything secured, and I don't have to worry about people phishing on my desktop if I do end up having a keylogger on there. And for organizations that have enterprise networks and applications and that sort of stuff, I cannot strongly recommend enough getting a password manager that you can use to keep all of your passwords securely configured in and stored that way. Phishing, we talked about phishing. So Fisher sends an email to somebody that looks like it's come from someplace reputable. They get all the credible. They have a credible information. They talk about something that's happened in your organization recently because it may have been public knowledge or whatever. and it's going to instruct the user to sign in and change their passwords or do something else and blah, blah, blah. But it just reroutes them to someplace else. It looks like the original website. It isn't. And then the hackers then have your information. Spear phishing is slightly different. This is a variant where a hacker builds a database about information around an individual, and then from there can create highly credible emails, right? So this is where you kind of get a little bit of espionage, where you're going and finding out about a person, and then you're going to get everything you can figure out about a person, and then use that as a way to get the information out of them as a spear phish. Your identity is your primary security perimeter. Knowing who you are is important. I know that sounds kind of weird, but knowing who you are and knowing what you do is the new security perimeter for organizations to secure their assets. Identity is how someone can access something and be verified, authenticated, authorized, and so forth. And this can be done either with a user, an application, a device, or any type of other methodology that you're coming in with, okay? And so here you've got partners and customers, you have employees, you have devices, you have on-premise applications, you have cloud-based applications. All of those things have an identity to them, and that identity can be used as a way to secure, first of all, the very outside, the very perimeter level of the application, how things are going to be used and who can get into them. So the four pillars that make up identity are administration, obviously administering the creation and management of the identities, the users, the devices. You as an administrator will manage how and under what circumstances the characteristics of the identity can change. So things like when it can be created, can it be updated, can it be deleted, that sort of stuff. Obviously the passwords can change and so forth. You might change your name. You might get married. You might, decide I'm going to start using a nickname. Whatever you can, those sorts of things. Authentication methodologies, right? How much assurance am I going to give to a particular identity, and how much is enough for them to be able to do the jobs that they need to do, and also is that sufficient proof that they are who they say they are? Okay, so this is the part of challenging the party. Credentials, right? So this is multiple factor authentication, where I go in and type in my username and password, and then I get a pop-up that says, please enter in this like a one-time only code, and you blah, 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 and okay, you're fine. You are who you say you are. Quite a few years ago, I was doing one of these sorts of things at a power company, and the company also had a trading division, so they would sell power that they made to other power companies for other distribution in other locations, mostly to the US. And it was quite funny because we were talking about security and usernames and passwords and stuff. And so a lot of the traders, because they worked at night, they all shared desktops on the floor. They had these desktop workstations, and they would all share them to do their emails and messaging and stuff like that. And there was one guy came into the meeting one day, and he was really excited. You could just see he couldn't wait to the question and answer section, because he had a bone to pick with us, and he was going to let us know that we're really making his life difficult. So when we opened the session up to question and answers, he was just like, he put his hand up first, like, okay, fine, sir, what's the problem? He goes, I have a real problem with what you guys have done with security. And I went, okay, so what's the issue? And he goes, I shouldn't have to, I shouldn't have to remember a username and password every time to log in. And he says, that's just stupid. The computer should just know who I am when I sit down to it. And I said, okay, well, how do you expect that the computer would know who you are when you sit down to it? And some of you may see where this is going. And he goes, well, I should be able to just tell it something and it'll know it's me instantly as soon as I tell it to it. I said, like a username and password? And he stopped dead in his tracks, and you could just see the stare coming out of his eyes like, damn you. A bunch of the people in the crowd started to giggle, but it was one of those ones where he thought he'd like, yeah, I'm going to get this guy, I'm going to roast him, and then realized that, wait a second, that's already what I'm doing. So so that whole challenge part, the authentication part, was doing its job. Authorization is the process or the location that you determine whether or not the person has access to that data. Okay, so I live in London. We have the Buckingham Palace. To get into Buckingham Palace, you have 2 layers of security to get through. First of all, you have to be authenticated. So at the outside iron gates, they basically validate that you are who you say you are. The second layer of security is the guards that are standing near the doors, and they're determining whether or not you have authorization to actually enter the building. So you might have authentication privileges. You might be authenticated to actually enter the Buckingham Palace because maybe you're a gardener or something like that, but you're not authorized to actually go into the residence, right? And so really that's what we're doing, is that we're putting up these layers of security. So yeah, we authenticate you. We know who you are. We say we know you are who you say you are. Next, we need to determine whether or not you need access to it. So when I go to access a piece of data or I go to access an application, the system will look at my access token and go, is he authorized to access this? And if he is authorized, what level of authorization does he get, right? So if I have read access to a folder someplace on a file share, then my security token will have on it that Brent Dawson can access this directory and he can read this file. And so when I double click on the file will open, I'll be able to read it. I won't be able to edit it, I won't be able to delete it, any of that sort of stuff, because my only authorization on that file is to read it, okay? If I was granted no access, that even though I'm authenticated in the system and I have a right to be in the system, I don't have a right to access that data because I've been denied access to it. So I can't do anything with it. And that's where the auditing tool part of it comes in, because this will track so who does what, who does what, when, where, and how, including in-depth reporting alerts, governance of identities, automatic remediation of breaches, and all sorts of different things that can be associated with that. So those are the 4 A's, the 4 pillars of identity: administration, authentication, authorization, and auditing. And those all have to work hand in hand, otherwise the systems could have major failures. Okay, so where are we here in my slide deck? We are at... All right, so modern authentication and role of identity providers. This is the umbrella that's used for authentication and authorization between the client and the server. So we have IDP, which stands for information data protection. These are for different layers of information within the system. From here, we can keep track of all of our data and information around this data. We can establish authentication and authorization policies. This is also where we would support things like single sign-on, where we sign on into one system and it automatically gives us access to another without having to re-sign in again. This is quite handy. And so an example of an identity provider is Azure Active Directory or even Windows Active Directory. But these are ways that we can control and look at those 4 pillars that we did in the previous screen. So the concept of federated services, which is one of the tools that's part of this process, is the simplification method of federations, where I have a user in one organization that needs access to a resource in another organization. And the identity providers existing between 2 sides communicate with each other and have a trust relationship that exists between them. When the user in one authorization group tries to access a resource, then the identity provider will communicate with the identity provider of the destination, validate that the trust relationship is there, and needs to be able to access that resource, right? So when the user goes to access the website, the website for IDP-A will communicate with IDP-B, validate they're a valid user, and then send the credentials passed back to the website, at which point the user is trusted and allowed to access the resource and any content in it. So the directory services and Active Directory structure, this is hierarchical, stores all the information and objects. This is a central component and organizations with on-premise Active Directory. And Azure Active Directory is the central location for any access management to the cloud, such as identity as a service and any of those cloud applications. Okay, so the second group here is what is Azure AD and sort of the identity types and stuff around it. Azure AD is the cloud-based identity and access management service, including structures for organizations enabling employees and guests, managing sign-ins, access to resources, is the single sign-in system for cloud and on-premise applications, and is enabled as part of your Microsoft Office 365, Azure, and Dynamics 365 subscriptions, which have an Azure Active Directory tenant associated to it. And so this is how the Azure Active Directory works. There are 4 different identity types. There's users, which is an individual person, which is managed by Azure AD rather. And these are usually employees or guests of the company. Devices such as mobile phones, laptop servers, printers, and so forth. All of these devices need to have an ID that exists in Azure AD. A service principal is the identity for an application that gets created in a tenant and then is specified and shared across all the resources that need access to it, as well as managed identity. This is the type of service principal for managing identity providers and applications when using and connecting to resource that exists from within Azure AD and is authenticated by Azure AD. Identity governance is done through the governance lifecycle. And so here we've got, we have somebody that has no access because they're new to the company. Then they have their first job role. So when they join, they get a new digital identity that's been created to them. If they move to a different job role, then that initial identity that they created gets moved with them, and then it updates their access authorizations to apply to that new role. And then at some point in time, they leave. They get fired, they quit on their own, they retired, whatever, and then you have to remove their privileged access from that user account then. So that is a very simple way of looking at the Azure identity governance, that they start with nothing. They get their first set of roles, then they move in to get access to other things, hopefully removing the ones that they had previously if they don't need them. And then ultimately, when they retire, they completely delete the account. Sorry, entitlement management. So entitlement management is the way for us to access the different reviews. And so, sorry. So here we have a person who's trying to access the finance web app, Finkelsoft.net. And it was, they were trying to get access to it. And so what this is going to do is it's an automated request workflow management tool. This will assess assignments, it'll do reviews, and it'll have an expiration for access to a resource. And it'll do reviews of access as well. So enabling organizations to manage group memberships. It's also used to review and manage access to both users and guests. And there is a terms of use for this. It does allow information to be presented to users before they access the data. And you can also make sure that users read relevant disclaimers. So instead of them just getting the pop-up box and going, yeah, let's just go, they have to literally scroll through and at least pretend that they've read the requirements and so forth before they're allowed access to it. So that the terms of use capability is handy. PIM, which stands for Privileged Identity Management, allows you to manage, control, and monitor access to all the resources. So this is done as just-in-time privileged access, only when needed and not before. It's based on a start and end point, so they can only access the resources for a specific time. Again, it's approval-based, so somebody needs to actually approve the access. So if I go to access something, a manager would have to approve it before I'm allowed to get to it. Notifications when privilege roles are activated are sent to administrators, and it's fully auditable. so that people can look at the access history for that. The next thing we're going to talk about is a little bit of Azure identity protection. And the whole point of this is to enable organizations to do three things. First of all, automate the detection and remediation of any risks that are based on identity. Investigate any risks using data in the portal, or export data detection data. Export risk detection data to third-party utilities for analysis, such as Exchange or Power BI and that sort of stuff, or Excel and Power BI, I should say. You can also do categorization of data, low, medium, high, and then calculate in-risk sign-in capabilities, user identity risks, all that sort of fun stuff as well. There are three different reports that you can get. You can get risky users, risky sign-ins, and risky detections, so that you can actually see, who's doing what and what could potentially a problem. The Azure security groups concept in Azure is that the idea of the network security group, and this will allow or deny traffic to and from resources based on whatever virtual network you're accessing. And this could be associated with different virtual networks and subnets or network interfaces. And there are inbound and outbound rules. Network security groups are basically the equivalent of NATing in a on-premise environment, where you have a valid public public IP address, and then you'll specify the resource destination, directions, actions, privileges, and so forth, and port ranges for people to be able to access internally in your network, right? So everybody that's on a network security group can go out to the internet, but only certain individuals and certain groups with certain privileges can get into them through the virtual networks. And again, it works almost identical to the way that NATing does in a home computer, home networking system. There's built-in DDoS protection, as mentioned before. So really, DDoS makes networks unresponsive because it prevents any valid traffic from being able to access the network. And there are two tiers that you can get access to. There's the basic tier, which comes with your subscription, and then there's a standard tier, which you can purchase as a separate cost. The Azure Firewall, again, is another way to protect your virtual networks. Built-in availability, has S-natting and D-natting, which is basically the equivalent of natting. Does threat intelligence, multiple public IP address maintaining, and supports the Azure monitoring tools. So you can keep track of all of the information and have it in the central monitoring location. A Bastion is a way to provide another layer of security using TLS. And this has capabilities for supporting RDP and SSH. No public IPs are required, no hassles of managing network security groups. It helps to prevent against port scanning and zero-day exploits. So a Bastion is just another server that sits right in front of all of your network, your entire network infrastructure, instead of doing them in individual layers. The Defender is a portal that combines protection and detection for different types of things, such as incidents, hunting infrastructure, action center, threat analytics, and so forth. This is the central portal where you will do all of your defensive configurations and monitoring of your entire environment. This is directly connected to Microsoft's Security Center in Redmond. And so as things change, as updates are occurring to things like virus definitions and so forth, this is the system that will actually push that out to everybody who has access to it. The secure store, or sort of the secure score rather, is a way for you to give you a graphical or numerical representation of your security. And it shows you things like what's your overall score, how many things need to be addressed, how many things are planned, how much risk can be accepted, what is currently falls under identity, what falls under applications, and so forth. And it's a way for you to not only see where you are now, but it's a way for you to help improve yourself. So there's a tab there called Improvement Actions. And in here, the system will actually give you a list of things that it seems to think that would be good for you to remediate to make your system get a better score. And so this is the equivalent of the old health checks in some of the older Microsoft environments. The security reports and dashboards tool. So again, as part of this, we have a number of different reports. And this shows the general security report in this particular example. So we see that we have one user that's currently at a risk. In this case, it's a medium risk. It's saying that we should reduce the number of global admins, because right now we have 6. And it's looking at different data levels. So things like, is there any email that's questionable? Have we come across any viruses in documents and those sorts of things? So that's listed there as well. The two that we don't see are the devices. So a list of all the devices and whether or not they're all compliant in terms of security levels and patching and so forth. And the last one is apps. And this shows us all of the programs and attached applications that are part of our service. And you can group them in a number of different ways. These are basically just large PowerShell, Power BI reports that you can manipulate and go around and take a look at different data structures and configurations and so forth. Okay, so the next section is on compliance. So some of the common compliance needs that every organization needs to follow. So granting individuals access to data at any time, granting individuals the right to correct or delete data about them if needed, so that's important. Introducing maximum and minimum retention periods for data. This is something that most organizations struggle with on a daily basis because there could potentially be conflicting requirements for data management or data governance, such as government-based requirements versus industry requirements. So as an example, let's say that the government requires you to keep something for 7 years, but your industry requires it for 10 years. You know, which one do you follow, that sort of thing. So it's knowing how to access the data, how long to keep it, and determining where that data lives and so on. You know, there was at one point in time 2 different conflicting requirements in Sarbanes-Oxley, where you had to maintain data for 7 years. And in one place in the document, it said that the data could be stored off-site storage for a maximum of 7 years, but another place in the document said that the storage had to be live for 7 years. So which one was which? So they actually cleaned that up eventually, but that did happen. And defining rules for what data can be processed and how it should be dealt with. You know, if it's a hard drive, take it out and shoot it with a shotgun or throw it through a wood chipper or whatever you're going to do. If it's other data, you know, how am I deleting it so that I know it's permanently deleted? Privacy principles, control. You are controlling the data, so you have access to where it's living. You get to be transparent about it, what security is set up around it. There's very strong legal protections configured for it. There's no content-based targeting, so it's not using emails or anything to do advertising. And the benefit to you is that when Microsoft does collect data, it will benefit you, the customer, and to make the experience better. So they're not going and tracking information for the sake of tracking it. They're trying to make it better for you. The Compliance Center, which is another tool that Microsoft has, and this is part of Azure as well. This is going to show you how your organization is meeting its compliance requirements. And again, it goes through and does scores and takes a look at different layers of your system, and will then come up with solutions that can help you be more compliant. And it gives you access to alerts, reports, policies, all sorts of different things that you can basically look at, evaluate, and hopefully make your organization function better. It helps to reduce risk by looking at different assessments, taking a look at different workflows to complete the risk assessment, step-by-step improvement actions, as well as an overall compliance score, so you can see where you are. And the 4 elements that make up the compliance manager are the different controls that are used to do the testing, the assessments themselves, the templates that are used to help improve your organization's compliance, and the actions that go with them so that you can actually follow through and do the step-by-step improvements for your system. And then this score, again, it's just a score out of 100, and it helps you so you can understand what actions you should do to improve the system and what actions Microsoft should do as well. And what you would they consider to be mandatory or discretionary types of actions that need to be executed, right? So there'll be a total points achieved score, and it'll give you a total of what you need to have out of that score. In this particular one, it's convenient that Microsoft scored perfect and you didn't. So there's some things that need to be completed here and fixed up. So knowing your data, also knowing how to protect your data and govern the data. You need to understand the cloud datascape and the data landscape rather for knowing the data, how you're going to protect that data, how you're going to prevent data loss, and how you're going to govern it, right? Remember, automatically keep, delete, and store data and records in a compliant manner. Figure out what the compliant requirements are, and then keep your data around it so that you're compliant, but just to that point. Data classification is important because this is how you can store data and retrieve it efficiently. It helps to do sensitivity of information. It can be used as a training exercise for individual users so that when they're storing data, they classify it properly. It makes it easy to understand and explore the data, as well as being able to extract and retrieve that data when required and know who's been dealing with that data. So, who's made changes to it, what content has changed, and so forth. The sensitivity labels, sorry about that. My upstairs neighbor is dropping something, I don't know what. The sensitivity labels are customizable. They're in clear text and they're persistent, so they will stick with the content as long as the content exists. And as far as usage is concerned, it can be used in a number of different ways. You can do it for encryption of emails or documents. You can apply for marking of content, classifications without protection settings. You can do third-party app sensitivity labeling so that it follows with you if it goes someplace else. And then there's a number of label policies that you can apply. So things like user and groups that can see labels, and justifications for changing labels, and sensitivity of labels, and so forth. Once it's assigned and applied to an email or document, any configuration changes for that label are enforced on the content, so whatever you happen to change it to. So DLP, or data loss prevention, protects sensitive information and makes sure that it's inadvertently disclosed. And data protection can be used against pretty much all of the Microsoft products. Microsoft 365, OneDrive for Business, SharePoint Online, Exchange Online, and Microsoft Teams. And the DLP has been extended to Windows 10 and Windows 11 devices. And it sets up application policies and then the rules that are associated with it. So based on conditions and actions that can be configured for those particular items. The retention labels, again, are applied to each item, and they are going to be stuck to that document or email and travel wherever that content lives in your Microsoft 365 tenant. You can have them applied manually or automatically, and you can help with the disposition of data based on those rules as well and those labels. The policies are applied at the site and mailbox level, and again, if the item is moved, the setting does stick to, the label sticks to it, but the retention policy will change based on wherever the label is or wherever the document is moved to. Records management. Here we have a way of marking items as a record, and then this will help to organize and look after things like legal obligations and demonstration of compliance and so forth. So if there is an audit by an auditor, you can actually use this to show that you are in compliance with any requirements that you have. And the Azure DDoS protection, again, this is a big one. It helps to make the attack surfaces smaller. It helps prevent making resources unresponsive. And again, there are two tiers of Azure DDoS. There's the basic tier and the standard tier, and it will help to secure your network. I just need to flip slide decks here. Just give me a second. Is it? All right, so the next little thing I need to just go through here is the learning with the hands-on lab and getting certified with Microsoft servers. So there are two courses that primarily we're going to look at. The one is the SC300. This is a 4-day virtual class, instructor-led class. And the master class that you kind of just sat through is designed for in-depth 4-day training sessions and extensive hands-on labs that you'll get access to. So you'll get a virtual space with an Azure account. And when you're in there, you'll be able to actually do hands-on lab exercises. And you'll be able to then go through and be able to complete exercises. This is an interactive discussion, so you can actually have communications. You'll have communications with the instructor. You get 180-day access to the virtual labs for practicing after the course, during and after the course's completion. You get 365-day access to the recording of the instructor-led class. And then you also get access to the learner portal and free repeats and those sorts of things. And you basically can access those resources 24/7. So once you've got access to the recordings or to the virtual lab environments, you'll be able to access those for the 24/7 hours. Obviously, there are some certification benefits that occur. You can stand out. You get greater recognition. You can tend to get more of a salary based on the number of certifications and the level of certifications that you have, and can also help advance your career because it shows that you have the capability and the abilities to work with certain pieces of software and certain capabilities in your industry. You can, broadcast your certification skills quite often. You'll see people posted on things like LinkedIn or Twitter or that sort of stuff. And also you can attach it to your employer verification as well. So things like LinkedIn, you can attach your different badges and so forth to show that, you've achieved those certain certifications. It used to be that, you used to get things like MCSE and you could put labels, letters after your name. Now we've gone to more of a badge sort of scenario, which is a little bit more obvious, and you can put them into different types of marketing materials or organizational materials and so forth. Organizations that tend to maintain a good culture in terms of certification and continuous learning are often the companies that have the least amount of issues in their organization. So if you have a well-trained staff, specifically end users in IT, you'll be more productive, you'll be more efficient, you'll have fewer amounts of issues in terms of downtime and so forth. And so there is an ebook that you can download, and it's called The Win-Win of Certification. And that's available through, if you just go out on a search through NetCom Learning, you should be able to find the manual and be able to take a look at it. And it just goes through things like statistics and things like what happens if you do certification. How does it improve yourself? How does it improve your organization? How can it improve your pay and your management abilities, your capabilities, and the type of job that you have? So as far as the certification, the ST300 Identity and Access Management, Access Administrator, it shows you the skills there. Again, this is a 4-day instructor-led course. It will be a part of the way for you to be certified, part of the way to get you ready to be writing the certification exam. Nothing beats hands-on experience, but certainly having these instructor-led courses and understanding the topics and the requirements that are needed for the exam as the course is laid out towards the exam it'll make life passing the ST300 exam a little bit easier, a lot easier, in terms of being able to do this. And not only that, but showing that you understand the materials, but being able to implement them on a day-to-day basis. So some facts. Generally, the certifications will expire in 1 year. Some of them have been modified so that they don't expire in 1 year. Some are 2 years, but they all will do. They all do have some sort of a recertification process, and so you need to understand what they are. If you recertify before they expire, you don't have to write the full certification exam. You only have to do the renewal assessment. And you get notified of those about 6 months in advance before your certification expires. And you can rewrite them as many times as you need to pass them. They're not monitored. They're not like a regular Microsoft exam where you have somebody who's monitoring the exam for you. It is, in a sense, it is open book because you can take it when you're available to take it. And that's it. Let's get trained and certified. And thank you very much for listening to me drone on for almost 2 hours. And Leela, I'm handing it off to you.
Thank you so much. Okay, well, we are going to go ahead and now we're going to hear from Sagnik. He is going to go over some of the products and related courses to today's webinar. So let me go ahead and hand those presentation rights over to him. There we go. Thank you for joining us.
Thank you, and what a wonderful session, Brent. It's always a pleasure attending your, highly informative sessions, and today was no exception. Thank you so much for that. So I just quickly take this opportunity to take our participants over the collateral that they are getting as part of this session. We have created this event handout, and it really contains a gold mine of relevant stuff that all our participants would be, are welcome to explore and hopefully benefit from. So I'm just going to take you over so that it is a really guided experience for you all. So it has the session link recording as well. So when you go through, you'd get certain, information about what we are as NetCom Learning. We have we provide official training across multiple vendors, including Microsoft. We are a gold certified partner with Microsoft, but we also provide training across AWS, Cisco, PMI, Autodesk, all the leading vendors in the world of IT and business solutions. So please feel free to go through it. You would find the recording to today's session and the link to it. Also, an important aspect of it, please feel free to activate and explore your NetCom 365 Learner portal. The link has been provided here as part of this collateral. As part of this session, you would be getting access to SC900 and SC300 Microsoft official courseware. We are sponsoring that for all our participants today. So feel free to activate your NetCom 365 student portal if you haven't done already. For the first time, you would be required to set your password. So please follow the forgot password step to set up your password against the user ID, which is your registered email ID with us, with which you registered for this particular session. And you would find the mock materials, the official courseware, as part of the classes section. Apart from that, you'd also be able to download your participation certificate for today's session. So please feel free to explore this portal. It has a lot of things related to training and certification, so feel free to explore that. Currently, we are running an offer around Microsoft certification exams. As Brent rightly pointed out, the true value of upskilling on Microsoft is unlocked when you get that credibility and validation from Microsoft itself. So whenever you are undergoing a training, it's always wise to get that seal of approval from Microsoft through the certification exam. Currently, we are offering up to 40% discounts on the fundamental exam. So if you are interested in SC 900, you'd be getting that exam voucher for $60. And if you are interested in taking the SC exploring courses like the SC 300, which are role-based, you'd be able to get certified for $124. This offer is valid till January 31st, 2022, and it's only valid in the United States. So if you're interested, feel free to go through it. Also, you'd find the link to the Win-Win of Certification ebook. It is really an great collateral for decision makers and individual professionals to go through and understand, look at the data, look at the facts, data liberalize. So see for yourself what the changes, what are the impacts that certification has been able to provide over the years. And it's all in there. Please feel free to go through it and explore. We at NetCom Learning are also, trying to provide the best value in terms of the budgeting concerns. We understand upskilling is a continuous thing. And based on that, we are introducing the NetCom Plus Learner subscription. It is a great tool for individuals to continue their upskilling over the course of 12 months. They get access to 500 plus official training courses. Of over 60 Microsoft courses are included as part of the NetCom Plus subscription. It starts at $2,999 per learner per year, but if you are going for enterprise with more than 10 learners, the price comes down even further. We invite you to explore it. You get access to official courses across vendors like Microsoft, AWS, Cisco, CompTIA, and many more. Learning Passport, it is something which is specifically designed for the enterprise upskilling programs. It gives you a lot of funding bandwidth when it comes to employee upskilling. So it's again valid over 12 months. Feel free to explore these options for the upskilling requirements of your teams. We have included this particular slide as part of this capability deck. You'd be able to see all the role-based and fundamental security-related courses that are currently part of Microsoft's official training and certification portfolio. So SC 900 is the fundamentals. Today's masterclass was primarily based on that. We briefly also touched upon SC 300, which is the administrator associate level of certification. So all the courses are hyperlinked. Feel free to explore and take up things that you might find to be interesting and required as per your specific requirements. Also, please feel free to explore our upcoming free masterclasses. We are going to have a Power Platform masterclass later on in the month, and an Azure Data Fundamentals Masterclass coming up in the month of February. So please feel free to explore all of these wonderful assets that we have. And that's about it from my end. Thank you. Back to you, Leela.
Thank you so much. Okay, we will go ahead and jump right into our question and answer session now. Let me just share my screen real quick. Okay, so we're going to go ahead and jump right into our question and answer session. Our first question was, will the recording be available for the attendees? Yes, you should get that. Usually it's in the next 24 hours. I know on weekends sometimes it's not until Monday that you get it. Sagnik, do you know for sure?
Yeah, by Monday you definitely have access to it.
Okay.
So, yeah.
Okay, and then let's see, our next question we have is, when setting up a security and hybrid, is it best to make the on-prem system the primary one or the cloud?
Probably the cloud one, because ultimately that's where Most of the authentication is going to occur based on multi-factor authentication. So having the cloud at AD, Active Directory AD being the source of truth is the preferred method.
Awesome. And I'm not sure which part in the presentation this is referring to, so I'm assuming you will. They said another common thread should also list supply chain.
Well, supply chain would be that's more of a Dynamics 365 related thing. That's not directly related to Azure Active Directory.
Okay. Our next question, can you directly migrate on-prem add to Azure add?
Yes. Yeah, you put AD Connect on there and it would do direct connection. Do a direct transfer.
Okay, and sorry, AD, I was saying add.
Yeah.
And there's another one. Is there a limit to the number of users you can have in Azure AD?
No, you have to pay per user as part of your subscription, but there's no limit.
Okay. I see one other question. I just want to let everyone know we do want to get to all your questions, but once they run out, we will wrap up. So if you have any more, go ahead and get them in now. Is it necessary to have a firewall, I think firewall cloud base for my Azure environment?
No, you don't need the firewall. It's actually built in as part of your Azure subscription. So you won't have to pay for a separate firewall tool, separate firewall application, hardware. That's all included as part of the installation of Azure, as part of your tenant.
Wonderful. Well, it looks like that is the end of our questions. So at this point, we're going to go ahead and launch a quick poll to find out how many people might be interested in some additional training. Oh, let's see. They have a more personal question that just popped in. They wanted to know where in Canada you were from, and if you don't mind asking, because they were born and raised in Welland. Is that how you say it? Welland?
Yes, I was born and raised in Estevan, Saskatchewan, and I moved to England from Edmonton.
Awesome. Yeah. So, okay, so we've got that poll up. We want to thank you, Brent, for joining us. I know Saturdays are always a busy day. So thank you all for taking your time out of the day to join us as well. In addition to today's webinar, we have a lot of informative webinars that are coming up. So please go to www.netcomlearning.com/webinars/ to register for any of those. We want to thank you all for joining us once again. And if you do come up with any additional questions, please feel free to send them to us at webinar@netcomlearning.com at any time. We hope that you found today's webinar informative, and we look forward to seeing you back here with us very soon. Also, feel free to tell your friends and colleagues about our webinars and other courses. Once again, thank you everyone, and have a great Saturday.